Jai Hind everyone, I am Dr. Neha Singh, Assistant Professor in Department of Computer Science Engineering at Ajay Kumar Engineering College. Today we discuss the topic deep learning and its related topics. So first we know what is deep learning. So deep learning is basically a subset of machine learning, and uh, it's working like just like a mimic of the human brain to analyze complex unstructured data like in the form of images, text and sound. So now the question is arise, why it is called deep learning? Because of the multiple layers. So, that's why it is called a deep learning. So deep learning enables machines to automatically learn pattern and make predictions without explicit programming, and powering technologies such as computer vision, speech recognition, image recognition, self-driving car, recommendation system, and many more. So some of the key aspects of deep learning like natural language structures. So deep learning follows the neural network model like input layer, hidden layer, and output layers, and all the layers are interconnected with each others. So next aspects of data driven. So deep learning model is the vast amount of data to improve performance, often outperforming traditional machine learning techniques like with complex unstructured data. Key applications used in a deep learning like computer vision for facial recognition, natural language processing like chatbot, translation, speech recognition, and also autonomous vehicle and generative AI. So training process in deep learning model. So the model use iterative nonlinear algorithms to weights and bias between neurons and minimize the errors. Now, deep learning algorithms. How deep learning algorithm works? So deep learning algorithm typically trained on large data set of the labeled data set, like labeled data set, which means names or tags are given. So the algorithm learns to associate features in the data with the correct labels. For example, image recognition task, the algorithm might learn to associate certain feature in images like shape of an object and color of object with the correct labels like such as dog or cat. So if once a deep learning algorithm has been trained, and it can be used to make predictions on new data. For the example, a training algorithm that has been trained on the recognized images of dog can be used to train and identify dogs in new images. So basically deep learning works by using the artificial neural networks to learn from the data, and neural networks made of the multiple of layers, and each layer are connected to each others. So neural network learns on the weight, and the connection between the nodes are adjusted, so the network can be better classify the data and also predict the data on the unseen data. This process is called the training, and it can be done using the variety of techniques like supervised learning, unsupervised learning, and reinforcement learning. So once a neural network has been trained, it can be used to make prediction with a new data set it's received. Now, what deep learning and machine learning are the branches of artificial intelligence, with machine learning being a broader term encompassing various techniques including deep learning, and both machine learning and deep learning algorithm can be trained on labeled and also unlabeled data, so depending on the task and algorithm. So machine learning and deep learning are both applicable to tasks like image recognition, speech recognition, natural language processing, computer vision. Deep learning and outperforms the traditional machine learning algorithms in complex pattern recognition tasks like image classification and object detection due to the ability to learn hierarchical representation of data. Now, applications of deep learning. So deep learning can be used a variety of applications like image recognition. For the image recognition, identify the object features in images such as people, animal, places, and objects. And another application is natural language processing. So deep learning help to understand the meaning of the text such as customer services, chatbot, spam filters. Now it also used in a finance to analyze the financial data and make predictions about market trends. and also used for text to image and it convert the text into images such as the Google Translation app, and also use many applications. So types of deep learning. Basically, deep learning is a three types: convolutional neural network, deep reinforcement learning, and recurrent neural network. And the convolutional neural network basically used for the image detection and recognition and processing, and they particularly good for identifying objects in the images even when objects are partially obscured or distorted. So now next is a deep reinforcement learning. So deep reinforcement learning is used for robotics and game playing, and it is type of machine learning that allow to agent to learn the environment by interacting, and it can receive rewards or punishment. So now next is recurrent neural network. So recurrent neural network are used for some of the benefits of deep learning, like can learn complex relationship between the features in the data. And deep learning basically more powerful than traditional machine learning model, and also use large data set for training, and this makes them very scalable and able to learn from a wider range of experiences, making more accurate prediction, and also used for data driven learning. Some of the challenges of the deep learning, like data requirements. Do deep learning models are required a large amount of data to learn from, making it difficult to apply learning. Also overfitting problem. Deep learning models may be prone to overfitting. This means that they can learn the noise in data rather than the underlying relationships. Now next challenges in deep learning is bias. This model can potentially be biased depending on the data, and that it can be based on, and this can lead to unfair or inaccurate prediction, and this is the important tech step to mitigate bias in deep learning. Next is ethical concern. The future of AI involves addressing issues like bias in model, privacy concern, and ensuring the ethical use of the deep learning technology. Now next is a generative AI, general AI. So deep learning is a key area of research in the quest of artificial general intelligence. Now next topic is convolutional neural network, or CNN. So CNN is basically used for the specialized class of neural network and designed to process grid-like data such as images, and it also are particularly well suited for image recognition and processing tasks. So basically deep learning used for image recognition and object detection or a video recognition. So they are inspired by the visual processing mechanism in the human brain, and CNN excel at capturing hierarchical pattern and spatial dependency within the images. So here the image of the cola. So in using the CNN, first detect the eye, nose, ears, hands, and legs. One by one is detecting all the parts of animal, and then combining cola's head, then cola's body, and that identify this is a cola. So CNN is work like detect the images in layers by layers. So here the detect the image of 9. So first detect the loopy circular pattern, then vertical line, then diagonal line, then identify that this is the 9, image of 9. So number of layers of the CNN. So first is a convolutional layer. These layers apply convolutional operation to input images using filters, and also known as kernels, to detect the features such as edges, textures, or move complex pattern. And convolutional operational helps preserve to spatial relationship between the pixel. Now second layer is a pooling layer. They downsample the spatial dimensions of the input, reducing the computational complexity and the number of parameters in the network. So in pooling layer, two types of pooling is used: max pooling and average pooling. So max pooling is a common pooling operation, selecting the maximum value from the group of the neighboring pixel. So activation, now next is the activation function. They introduce non-linearity to the model, allowing it to learn more complex relationships in the data. Now next is a fully connected layer. These layers are responsible for making prediction based on the high level of features learned by the previous layers, and they connect every neuron in layer by layer to every neuron into the next layer. Now how CNN works. So first is the input image. The CNN received an input image which is typically processed to ensure uniformity in the size and format. Now next is a convolutional layer. After receiving the image, filters are applied to the input image to extract features like ease, texture and shapes. And then after that, a convolutional layer apply the pooling layer. The features map generated by the convolutional layer are down sampled to reduce dimensionality. And now next is a fully connected layer, and the downsampled feature maps are passed through the fully connected layers to produce the final output such as classification label and the output. The CNN outputs are predictions such as the class of images. Here the picture of here the architecture of the CNN. First receive the input image, then apply the convolutional layer, and then apply the max pooling operation, then pattern layer, then apply the fully connected layer, and then receive the output of the image. So CNN work layer by layer. So convolutional how convolutional neural networks parameters are used. So CNN are trained using the supervised learning approach, and this means that CNN is given set of label training images. The CNN that then learns to map the input images to their correct labels, and the training process CNN involves the following. Like first is the data preparation. So the training images are pre-processed to ensure that they are all in the same format and size. Then second is the loss function. Loss function is used to measure how well the CNN is performing on the training data, and the loss function is typically calculated by taking the difference between the actual value and predicted value. Then next is optimizer. An optimizer is used to update the weight of the CNN in order to minimize the loss function. Now next is backpropagation. So backpropagation is basically used to minimizing the loss function of the actual value and the predicted value. So applications of CNN, basically CNN used for the image classification, like CNN are the state-of-the-art models for image classification, and that can be used to classify image into different categories such as cat and dog, car and trucks, and flowers and animals. Also used for object detection. CNN can be used to object detection in images such as people's, car and buildings, and they can also be used to localize objects in images, which means that they can identify to location of an object in an image. Also for image segmentation and video analysis. So in the image segmentation and video analysis used to analyze the images or videos, like tracking objects in a video or identify the labels of different objects. Now advantages of CNN, basically high accuracy. CNN achieve the state-of-art accuracy in various image recognition tasks. Efficiency, CNN are efficient, especially when implemented on GPU, general processing unit. Robustness, CNN are robust to noise and variations in input data. Adaptability, CNN are adapted to the different tasks by identifying their architectures. Disadvantages of CNN. Some of the disadvantages of CNN, like complexity. CNN can be complex and difficult to train, especially for large data set. Resource intensive. CNN requires significant computational resources for training and deployment. So data requirements. So sometimes CNN needs the large amount of labeled data for the training and interpretability. CNN can be difficult to interpret, making it challenging to understand their predictions. So some challenges and limitations, like data requirement, computational cost, overfitting. Some of these challenges are faces to the CNN model. So here are some layers of the CNN model. First is the input layer. So in the input layer image, we give the input to our model, and generally the input will be image or sequence of images. This will be hold a width 32, height 32, and depth is 3. Now next layer is a CNN layer. So CNN layer, which is used to extract a feature from the given input data set. It's apply the set of learnable filters known as the kernel, and these kernel are smaller matter, usually 2x2, 3x3, or 5x5 shapes. So it slides over the input images data and compute the dot product between the kernel's weight and the corresponding input image patch. Now next is we use the activation layer. So by adding an activation function to the output of the preceding layer, activation layer add non-linearity to the network. It apply an element-wise activation function. So the output of convolutional layer, some common activation function like ReLU, TNS, likely ReLU. So the volume unchanged, hence the output will be dimension 32 into 32 into 12. So now next is apply the layer is the pooling layer. So the pooling layer is basically converts, and its main function is to reduce the size of volume, and which makes the computational fast and reduce the memory, and also prevents overfitting. And two types so basically two types of the pooling layer used: max pooling and average pooling. Now next is a flattening layer. So the resulting feature map are flattened into one dimensional vector after the convolutional and pooling layer, so that can be passed into completely linked layer up for categorization and regression. So next is a fully connected layer. So in fully connected layer, input from the previous layer and computes the final classification or regression task, and each layer in the fully connected layer connected to each other. Now next last layer is the output layer. So the output from the fully connected layer then fed into the logistic function for the classification task like sigmoidal or softmax function, which converts the output each of the probability score of the each class. Now next topic is a case study for diabetic retinopathy. So diabetic retinopathy, also known as diabetic eye disease, and it is a medical state in which destruction occurs the retina due to diabetics mellitus. It is a major causes of blindness in advanced countries. So diabetic retinopathy influence up to 80% of those who have had the diabetes for 20 years or more. So it is also main cause of the blindness in the people of age group to 20 to 64. So diabetic retinopathy is the outcome of the destructions to the small blood vessels and neurons of the retina. So objective of the diabetic retinopathy is to develop the convolutional neural network best for automated detection and classification of diabetic retinopathy from the retinal funds images. So first is the problem statement. So in diabetic retinopathy is the leading the cause of blindness. So by damage the retinal blood vessels due to the diabetics. So early detection is a crucial, but manual diagnosis by orthopologist is a time consuming, subject to variability among the doctors, difficult to scale in remote areas. So CNN based deep learning approach is used for automated and accurate diabetic retinopathy detection. So data set. So popular data set used for diabetic retinopathy classification use the Kaggle data set, MIS-DOR data set, ID-READ data set. So we classify the diabetic retinopathy in 5 labels: no diabetic retinopathy, mild, moderate, severe, and proliferative diabetic retinopathy. So next is a CNN based model architecture. So first is a feature extraction with CNN, and second is a pretend CNN model. So in a feature extraction, first take the input, process fund images, and then applied the layers like convolutional, ReLU for activation function, and use max pooling layer, batch normalization, and fully connected layers. So now pretend models are ResNet 15 and Inception V3 used for the feature extraction and fine tune for diabetic retinopathy dataset for better accuracy. Now, fourth step is use the training and optimization method. In a training optimizer, first use loss function for categorical cross entropy, optimizer used for Adam, and data augmentation is used for rotation, flapping, constant enhancement to simulate real world conditions, and evaluation metrics used like the accuracy, sensitive specification, AUC, ROC curve. And now next step, use the deployment in real world application like cloud based AI diagnosis, mobile AI apps, aged AI. Now next step is used result and performance. So accuracy is 94.6% on Kaggle dataset. AUC ROC score is 0.98, and diagnosis time is less than 2 seconds for images. Now the conclusion in diabetic retinopathy with using the CNN model is the based on deep learning significantly improves early diagnosis of diabetic retinopathy, making faster, scalable, and more accurate result. For future which include like self-supervised learning for better generalization, integration with optimal character tomography scans, feed rate learning for privacy preserving AI in hospitals. That's all. Thank you.